So in this experiment, we took this particular strain, which we would now call a variant in COVID speak, 675A, which was isolated from the chicken farms in the States, or a chicken farm in the States in the 1990s. And then we experimentally infected 10 birds with that virus. And then we put those birds together with 10 birds that didn't have any virus or any vaccines. And we put those together in our isolators and let the situation play out. In those situations, what happened was that all of the chicks that we infected were dead by day 10, and none of the sentinel birds got infected or died. So this particular strain, 675A, is so lethal that it kills all of the birds. And it kills them so fast that the birds never become infectious. And we know that because, well, we measured it, but also when we take the dust from the filters, we can see that there's no virus being produced in the air. So this virus is so lethal, it kills all these birds before it has a chance to transmit to other birds. Then we took the first generation vaccine, we vaccinated those chickens, and then we infected them again with the 675A. And in that case, what happened was all of the unvaccinated birds died. And they started dying after 4 weeks, and they were all dead a bit over a month and a half. And we again know, because we're measuring the virus in the air, that we know that those birds that were vaccinated, they shed virus into the air. So the vaccine kept them alive, and they then were able to shed the virus into the air, which the other birds picked up, the unvaccinated birds picked up, and that killed them. So this is the fundamental result of our paper, that vaccines, which aren't able to stop transmission, can keep variants going that are more lethal, that are too lethal to persist on their own. Okay, so just want to say that again, what these experiments show, and as I say, there's a number of them, that the vaccination here doesn't stop transmission, keeps the birds alive. It's very good at that, keeps the birds alive. And that means that viruses that are unable to persist normally, that can't spread because they're too lethal, are now able to spread. And just to reemphasize what's going on here is, so there's two variants here, and this is like what I showed for myxomatosis before. This is a density of virus particles that are going to be shed from the feathers through time for the two strains. So the left strain is what we would call a benign variant, and the right strain, the red one, is the 675A, the nasty one. And so if you vaccinate with the first generation vaccine, then it reduces the amount of virus that's going to be shed from the chickens, okay, by 2 or 3, 100-fold or maybe 1,000-fold reduction in the amount of virus. But it doesn't stop the shedding. The shedding still goes on. So virus is still coming out of these chickens being passed on. In an unvaccinated bird with the very lethal strain, the virus starts to be shed, but then the birds die and there's not enough viruses being shed by that point to spread on. If you then vaccinate, that strain is able to persist in those chickens because the vaccine is protecting the chickens from death, and that virus is now able to produce transmission stages that are shed into the environment. So the vaccination has kept the birds alive, and it made it possible for hot strains to spread to other birds. And that was our finding that we reported. I'm still very proud of that paper. I think it stood the test of time very well. There are quite a few, quite a bit of discussion that I wish some folk had read in that paper, but the abstract is pretty blunt about, if you've got a leaky vaccine transmission happening, then highly virulent strains can spread.